Lagi proses. Silpangan suara.
Okay. Sorry, sir, your sound is not good. Yeah, please.
Silpangan.
Huh?
Sil.
Better, but your sound is not not louder. Can you louder again or maximal? In this, my laptop is 100%, and then your sound is same with before. Suaranya nggak ada. Gue kecil ya. Ah, it's good, thank you. Now it's good, thank you, sir. Okay.
Ini udah proses.
Okay, I have adjusted microphone. I hope to be fine now. Okay, so my name is Jānis Junins. I'm a training and support service engineer in integrated systems team, the SPH engineering. So our today training session is UGCS area scan and true terrain following. Low altitude flights with different payload sensors. In your case, it's Magnimbus sensor. So first, I'll explain difference between true terrain following flight and flight when we just when we use drone native autopilot. Additional safety considerations for these low altitude flight specifics. Then how to plan, how to create automated route for such mission, and also show the flight process, how to start the flight, how it's possible to pause, and how we can change the battery and resume flight from the last known location or from different position. Before we start, was everything fine with all the previous trainings? So with assembly and setup of the equipment. Maybe there are some questions after the previous sessions.
We have nothing question, sir.
Okay, then
Okay,
then we can
good.
continue. If something comes in mind, I know regarding the setup or UGCS basics as well, then I'll be happy to answer. So We'll start just by showing the route, how it looks for true terrain following missions, and explain the specifics. What's difference from standard flights? Do you have a previous experience already flying automated missions with this DJI drone?
Yeah, I have.
Oh, okay, great. So for explanation, I'll use UGCS and just show how the route is created. So any automated flight which we execute, so it consists, we create route which consists from separate waypoints, and when we before we start the flight, so we upload this route to the autopilot. So at the end, that is that's list with the coordinates of separate points, speeds, how to fly between these points, and any actions if it's necessary to execute. When we fly using the native autopilot, all the flight altitudes are actually set relative to the drone takeoff position, or if we upload when the drone is airborne, then the drone just receives coordinates and flight altitude AMSL about median sea level, and drone during the flight, it maintains the altitude based on barometer, sensor, and GPS corrections, and all the flight is actually performed relative to the drone takeoff position, and that's because DJI drone in its default configuration, it does not have any sensor which is used to measure the flight actual distance to the ground during the flight. The drones are equipped with downwards obstacle detection system with landing assistance, but those sensors are only used for the safety to prevent the crashes, but they are not used during the flight to measure the actual altitude above the ground. So drone completely relies on barometer and altimeter. With this setup, we can perform relative safe flights on altitude, which allows the mistake for the altitude calculations. So it's safe to fly, say, 10 meters or 20 meters above the ground, but we cannot fly really low like it's necessary for the magnetometer. Because all these automated routes, we plan the altitudes, flight altitudes relative to the digital elevation map data, and so the flight, how correct are these altitudes directly depends on digital elevation maps which we have. Of course, we can use high accuracy survey grade digital elevation maps created using the LiDAR, but creating such data is very time consuming, and so for some locations might not be available, and so on. So to be able perform low altitude flights, we have the Skyhub to which we connect the altimeter, and this altimeter is used to measure the drone altitude, physical, above the ground in real time, and adjust the flight altitudes according these measurements from this altimeter. During true terrain following flight, the flight is controlled by SkyHub. So DJI Autopilot is actually not controlling the drone. It's so SkyHub takes telemetry from drone other sensors like barometer, accelerometer, GPS, and use this data for the navigation. But flight altitude it maintains based on this altimeter readings. Next thing, as we have additional equipment installed below the drone, it is required to disable DJI downwards obstacle sensing system, and as well the landing assistance. Sorry, I had to pick a phone call. Sorry. Sensors must be disabled, otherwise there will be false. Will give a false positive when detecting Magnimbus, and will not be able actually to fly at low altitude. Even flying without the Magnimbus attached, if the downwards obstacle sensor system would be enabled, it will interfere actually with true terrain following, and it will not allow fly very low, like we need 1 meter about just 1 meter above the ground. So next thing, so the safety specifics for true terrain following flights. First thing, return to home, which is still controlled by DJI Autopilot, and it has default DJI Autopilot behavior. This return to home behavior is described in DJI user manual, but we have came across that in different user manual versions there's different description. But it's written that default action is expected that if the drone is closer than 30 meters from home location, it's expected that the drone will take altitude 20 meters above the home position if it's lower, and then fly to home position. But in reality, so we have observed the behavior in the testing, and it has been reported also by our customers that if you start a return to home when the drone is in a close proximity, so closer than 50 meters from the home position, drone will not change the altitude. It will just fly in a straight line to the home position. So this is very dangerous in the case when we're flying with the Magnimbus, because then we are around 1.5 meter above the ground. And if we trigger return to home, well, when drone is close to home position, so drone does not change its altitude, just flies in a straight line to home position, and during this flight, it's not using Skyhub and altimeters connected to Skyhub, but switches to barometer altitude. So for the safety purposes, we strictly recommend not to use return to home functionality when the drone is close to the home position. And to avoid to avoid any accidents, it is better not to use automatic return to home at all, because if you will continue if you want to use it, then you need to pay attention to the distance from home location when you activate it. And sometimes it can just there is a place for the human error, that at some point you just do not notice that you're too close to home position and activate this return to home. So uh, when it's necessary to change battery or just fly the drone to the home position, always do that manually using the remote controller, and do not use automatic return to home. As return to home can be triggered also automatically because of low battery or loss of remote controller signal. So we still need to configure it, and we had to consider that it can be triggered automatically. So for uh, mm, so to when it's triggered automatically, we can allow drone fly to the home position. Of course, if it's on the far distance and it's not starting this movement just on straight line. So if you see that return to home is triggered, so first of all, the message will appear on the remote controller. Also, remote controller will start emitting sound. And if you see the drone is actually ascending, so it goes higher, you can let it mm, fly to the home position and pause the auto landing. Uh, so that can be done by pressing on hard the physical button on the remote controller. So if you press on a return to home button on the remote controller, then the automatic return to home is stopped, and you have the full control over the drone with the remote controller. And so you can allow it come to the fly to the home position, and when it starts landing, when it has stopped, you can take control over manually and land the drone manually. Uh, as during return to home, especially if drone is on the longer distance, so it accelerates to its maximum speed, which is around 50 meters per second. Uh, it will not be safe to stop return home when the drone has accelerated to this maximum speed, because if it's drone in the flight and you cancel return to home, then the drone will stop immediately. And with Magnimbus sensor, that can cause very high shaking of the sensor, and that can be dangerous. So if return to home is started, uh, if you still are able to cancel before it starts to accelerate, then it's fine. But if it has start already flying to the home position, it is better than allow it to reach home position, and when the drone already slows down in return to home to mode, then cancel it and take control over for the manual landing. So this return to home I'll mention also later during the route planning. So that is a really critical part of the flight, and if accidentally it happens that this return to home is triggered with this close when a drone is close to the home position, uh, there is a risk that the drone might hit the ground. So this is really important safety thing. So next thing is true terrain following algorithm behavior. So during these low altitude flights, Skyhub is controlling the flight, and it maintains the flight altitude based on the altimeter readings. Altimeter readings Skyhub receives with very small latency in some tenths of millisecond, and it also if necessary, if it's required to adjust the altitude, so it reacts mm, also in milliseconds. But for drone, some time is necessary to physically change the course. Well, because needs to change the motor spin. So we consider that. This terrain following algorithm, it has a little delay when flying over the terrain with changes in the elevation. We consider that this for safety for safe flight planning, we consider that this delay is around 1 second, but actually it is less. It's maybe half second. We don't have very accurate measurements say, but so just for the planning safety, we consider it 1 second, but in reality it's less. And this 1 second delay, so what it means for us in the flight. So altimeter is mounted on the drone near somewhere near the body, so it's measuring the altitude just right below the drone body, so in the center of the drone. First of all, we do not have any measurements from the front propeller. So if we are flying in the area with some obstacles or where the elevation is changing, the front of the drone, so the front propeller, may be actually closer to the ground than we have the altimeter. And if we are fly towards the hill, so of the slope, uh, depending on what's the degree angle degree of the slope, if it would be if it's higher than 10 degrees, then the speed at what we fly becomes quite critical, because if the drone is flying too fast, it might simply might not be able to adjust in time its course and stand when flying uphill. So there is a chance to hit the ground. So when we fly uphill, we need to decrease the speed. Taking into account this delay, so to give drone enough time to correct the course. So uphill, I would say that this speed limit for the safety, it should be less than 3 meters at least. So depending on the slope. So speed. Speed when flying on areas with elevation changes. That's one additional thing which we need to plan and observe the area to give the drone always enough time to correct the course. If we're flying downhill, then also because the altimeter is mounted in the center of the drone, again, we have measurements below the drone. So if we fly downhill, so we have the altitude right below the drone. but the back propeller of the drone again would be actually closer to the ground than we have the front. With Matrice 300, it has quite a large wingspan, but maybe not so big as M600. So if we fly over the slope with 30 degrees or more, that and we need to plan set actually the flight altitudes and higher to take considering this that the distance from back propeller will be actually lower than we have for the altimeter. Next thing is are obstacles on the ground. So drone can so from altimeter is measuring just altitude below it. So if you use a radar altimeter, then it has around 10 10 degrees beam. Laser altimeter is just measuring a single point, but that's altitude straight below. And a drone can correct the course over the obstacle only when it's already over this obstacle. So if it's in front, then when flying towards, for example, bush or rock, we do not have data about this obstacle for the navigation. So we cannot correct altitude before we reach it. That means that when planning the flight, we have to set the altitude which is actually higher than any such small obstacles on the ground. So if there's a vegetation, then we need to set the flight altitude above this this vegetation to be able to safely fly over it. Also, same with the rocks. So, for example, if there are let's say some larger rocks which are some 30 centimeters above the ground, then we need to have the altitude where our sensor is at least some 20 centimeters above these obstacles. So when drone flies, moves in on a straight line, so it can safely pass these obstacles even without the altitude adjustment. For as a downwards obstacle detection system where DJI is disabled, altimeter works also as a fail-safe mechanism for altitude changes where the altitude is too low. So for the altimeter, we have two configuration parameters: minimum altitude and maximum altitude. If altitude readings goes outside of this range from say in example it's 0.5 meters to 2 meters, so if it goes outside of this range, then the failsafe is triggered and the drone stops, and it stops immediately and ascends to the safe altitude. Safe altitude is configurable parameter, but by default its value is 5 meters. So if we fly and we get too close to the ground, the drone will stop and ascend to this failsafe altitude above its current position. After the failsafe is triggered, we can control the drone manually, so we can adjust the course and resume the flight and continue flight after we have corrected the drone position manually. Other scenario when failsafe can be triggered is if we fly over some slope or rock and altitude readings goes above this maximum value, which is 20, then also to prevent drone from falling down and trying to reach the ground. So failsafe is triggered, and we can adjust the course manually and then continue. Other case scenario, well, failsafe can be triggered if we attempt to start the flight when drone is outside of this range. So to be able to start automatic flight, we must have first of all the route altitudes in this range, and also when you fly close to the position and before activating terrain following, so we manually need to get the drone in this altitude range. And the last possible scenario when failsafe can be triggered if SkyHub doesn't detect readings from altimeter, if something goes wrong with the altimeter during the flight. If there are no readings before activating the terrain following, it will also instantly trigger failsafe, and it will not even start to terrain following. Mm, to understand that failsafe is triggered, so it's very easy. You just see that the drone just stops and ascends above its current altitude. And so those are the main safety things. And one more thing in the route in the flight planning, we need also to set safe initial speed. So the speed at which the drone moves to the start position on the route from the position where you activate. So usually in the field, it's recommended that you perform the takeoff and then fly close to the position, start position on the route, and activate the terrain following. So if you are on some distance from this first position, the drone goes to this position with default initial speed, which is 5 meters per second. But that parameter can be adjusted, and that I'll show also how it can be adjusted for a specific route, or how you can update default settings depending which way you will find more reasonable. For the altimeter, we have configuration parameter 0 level meters, which setting we can where we set the offset from the altimeter to the ground with payload sensor attached. So that would be from the altimeter to the bottom of Magnimbus this leg. Then when it's set, then all the flight planning we can specify the actual altitude from the sensor to the ground. But with current firmware version, this parameter is broken and it's not working. So when planning the flight, we always consider the altitude from the altimeter to the ground, not from the sensor. So are there any questions so far? Maybe something I didn't explain clear, and there are some doubts. Please don't hesitate. Please ask questions if there are any. So no questions so far? Okay. Okay, then next thing, so we can switch to the flight planning itself. So there are two types of routes which we can use for this true terrain following flights. So one is when we fly all during entire route, the altitude is maintained based on the altimeter readings. The other method is when we can combine with the native DJI sensors. So first, simplest and most commonly used case scenario, when we use altimeter altitude through the entire flight. So when we do the planning, so first of all, we start by marking the area over which we need to fly and collect the data. So for that, we use area scan tool in UGCS. So we select the tool, create the polygon. Polygon ideally is to have the regular shape polygon, but in some conditions it might be necessary to adjust the shapes. So the shape of the polygon can be adjusted according to your requirements. Next thing, we set the flight altitude at which we'll be flying, and we have to choose altitude mode rangefinder. So this is rangefinder's altitude mode when the altitude is maintained based on the altimeter readings and flight is controlled by the SkyHub. Then we set the flight altitude with Magnibus magnetometer, depending on what altitude above the ground you would want to have the magnetometer sensor. So if we would set flight altitude 1.5 meters, then we would have the sensor around 50 centimeters, maybe 70 centimeters above the ground. So we set altitude mode rangefinder and choose the flight altitude. Next parameter usually set is side distance. So side distance we configure depending on how dense data we need to collect. So side distance completely depends on the output survey output results which you are expecting. The minimum distance between the lines which currently we can configure it's 1 meter. That's a restriction still by DJI Autopilot. So with those with DJI Autopilot, we cannot set side distance less than 1 meter, distance shorter than 1 meter between the two waypoints. We are changing this algorithm on SkyHub to be able to use shorter distance, and technically we would are able to upload the route where the distance is less than 1 meter, but currently there have been observed issues with the flight accuracy when flying with these two close lines. So for reliable flight results, currently we need to still use the distance 1 meter between the lines. Nice thing is flight speed. So flight speed at what the drone will move over this area. There we can for the beginning we would recommend to that flight speed does not exceed the flight altitude. So flight speed meters per second doesn't exceed the flight altitude in meters. And there we take into account altitude measured from the payload sensor. So from Magnibus, if you fly having half meter above the ground, the sensor then for the first flights, would recommend to set the speed maybe even 0.5 meters per second. But that is just general recommendation for the safety. So we are certain that flying with this relation, it would be safe and the drone would be able to maintain necessary altitude in quite difficult survey areas. With time, when you get more confident and you understand this altitude, how the altitude is maintained, and how drone flies, and when you feel safe, you can, of course, increase this flight speed. With particular MagNemo's sensor at the altitude 1.5 meters above the ground, our team has flown even with 6 meter per second speed. But that's over completely flat ground, and I could say that that was like test flight to see how it behaves, and there was taken some risk, but technically we know that's doable. So for beginning, we start with slower speeds. Once you get familiar with drone behavior and observing the survey area, you think that it's safe to fly faster, you can of course increase the speed. Now, when we have created the survey area, we cannot choose from which corner the flight automatically starts. So it's calculated just automatically. And to change that, we can use the first waypoint tool. So we can add a waypoint before the main survey area, and this waypoint can be the same altitude like the survey. And then by moving this first waypoint, we can change the direction and from which corner the flight actually starts. And using first waypoint also can from which you want to start the survey, and you place this waypoint outside the survey area, so not corrupt the data inside the area. And when you start the flight, so first you just get the drone close to this position and then activate the automatic flight mode. So just a little before I mentioned the parameter initial speed, so at which the drone flies to the first position on the route. This parameter we can modify for each route in route properties, set initial speed. So this initial speed parameter, or you can modify also the drone profile. So in UGCS settings, in main menu, profiles, the drone profile, and here set this initial speed parameter, for example, to something slower, not 5 meters per second, but well, some reasonably slower speed from at what the drone travels from the position where you activate terrain following to the first position on the route. And if you modify this parameter here, then you will not need to do it each time when creating the route. You can even duplicate the drone profile and let's say create copy and call it TTF profile with such parameter, and then when planning the route, when creating, so you can just select this specific drone profile. it won't adjust initially, but next time when we create the route with this profile, then it will have this initial speed set slower. Um, so this is this is a simplest approach when we fly the entire route using the altimeter readings, and probably the most used tool for all types of data collections, actually. So, are there any questions so far? Yes, please. So, yes, just a second. So, uh, at some moment during the flight, when we use also the SkyHub, we can have 4 different altitude measurements. So first altitude, and which is most commonly used in the drone flights, and which you will also see in the on the mobile application, is drone altitude above the home location, and this is measured by a barometer. Barometer, so that's barometric altitude, which might be corrected by the GPS. But yeah, so we're not measuring uh, uh, actual distance, but this is measured just by barometer. So based on the barometric pressure changes on the sensor. AGL altitude, which we use for automated mission planning in the flight software, that there we set altitude above the ground, but the ground is actually digital elevation maps, so digital elevation data. And this flight altitude is maintained actually by the same barometric altitude. Just in the flight planning, we adjust these altitudes relative to the home position, but that's still flown using the barometric altitude. AMSL altitude, that's altitude above median sea level, which is measured by GPS. So the data we where we get altitude from GPS. TTF altitude equals the same as rangefinder altitude. That's where we measure the altitude using the altimeter. So during the flight planning, depending on which altitude mode we have selected, so if we select AGL altitude mode or AMSL, then the flight altitude is maintained based on barometer. So that's actually barometric altitude. And if we use barometric altitude, the drone knows only one place where the ground is its takeoff location. That location is set at 0. In any other position during the flight, the drone has no data where the ground is. rangefinder, that's this true terrain following altitude mode. When for the altitude maintenance is used readings from this altimeter which we attach to the drone. So when we want to fly low using the altimeter readings, we need to set the flight altitude mode rangefinder. So the simplest way and most common flight scenario when we're flying with Magnimbus or other sensors which requires low altitude flights, we set a rangefinder altitude mode for all segments on the route. So starting from the first position, drone will maintain altitude based on these altimeter readings. Maybe a bit longer. Just on. Maybe I didn't explain something unclear before. So does it make sense now? Do you now understand this difference between rangefinder and other flight modes? Yes. Yes. Uh, if there are trees, then definitely elevation model, because mm, so as I mentioned before, so with altimeter we can fly only. The altimeter is detecting only objects below it. Let's say I'll just use paint to explain it. So let's assume we have the ground and there are bushes. Let's say there's rock and there's a bush. So if the drone flies, so it's measuring the altitude only below it. So the drone would be able, when it is over here, so it will be able to detect the rock and it can correct the altitude. But if we fly and there's, for example, bush or large tree, we still get measurements only here. We do not detect that tree or whatever which is higher than the drone. To be able to fly over it, we must be higher than this obstacle. If there are trees, tall trees, then in terrain following, if we set 1 meter below, we cannot fly at low altitude. So if we would have say ground area and there are trees, different altitude. So with altimeter, we would be able to fly only specifying the altitude about here, but then let's say this distance is 50 meters. Then when it flies over the tree, it will ascend again 50 meters higher. So with altimeter on the such environment we cannot fly. Then we need to use AGL mode, so digital elevation maps, because in digital elevation maps, so digital elevation maps, they contain ground elevation. The vegetation and buildings are not present on that. If data is collected using the LiDAR, and then it's possible that you get digital terrain maps. So where also the vegetation and buildings are present, but that's custom collected data. In UGCS here, the data which is used, for example, we have some locations where you can see the forest. So here, for example, here's a forest. Yes, if I would create the route here. And if I select AGL altitude, so that's above altitude above digital terrain elevation. If I set, for example, 25 meters. Okay, just increase the sign distance. So we can check elevation profile. So this elevation is above the ground. The trees are not actually present here. So to fly safely over the trees, we need to set this altitude higher than actually these trees are. So if you say 40, could, could you tell again how tall those trees are? You mentioned 40 feet or 40 meters? 40 meters. Okay. That so if the trees are 40 meters from the ground, then I'd say definitely you cannot use altimeter. Then you need to use AGL, and if those are 40, then safe would be to set something like 60 meters above those trees, because elevation data, if you have your own created using if you create your own elevation data where you know as the accuracy, then maybe you can fly lower. But if relying on the digital elevation maps which we have in UGCS, so those are created using the satellites. First of all, the accuracy for this data is not very high in the areas with elevation changes. It might be off for some even 10 meters. Other things that data can be might be outdated, and the terrain also can be changed. So especially in the areas which the vegetations, I would say that for the safe flight, you need to set some 20 meters above the height of vegetation. So if there are trees 40 meters, and that's probably approximate, then you set at least some 60 meter flight altitude. Also depends on what is the terrain. If that's area like this, where you also need to fly up the hill, so 20 meters is definitely. If that is flat, like a flat forest, you can measure actually the altitude of this tree, so to get more accurate measurements. So you can just fly with the drone manually, check from the FPV camera when the drone is actually above these trees. Then you can see in the application what's the actual altitude. Then okay, maybe 10 meters above this, that would be probably the lowest point what I fly. But still, the higher the better, because you need to remember that when you fly with magnetometer attached, there's no downwards obstacle system working. So if you fly to the H3, okay, for side sensors, forward sensor will be working, but no down sensor working. So there is quite high risk of collision. And with the altimeter, you definitely cannot fly over the tall vegetation. So AGL, that would be the must. Yes. Uh, I unfortunately don't have this information. Uh, I know with regarding a magnetbus, I'm not certain. I'm certain with other kind of magnetometers, the flights are performed also at the higher altitudes. So it all depends on the data. So what are you expecting for the in the target data? So uh, what's the purpose of your survey? I'm not sure. Will you have also the course of magnetometer data interpretation and basics of magnetic data processing? Oh, yeah. Yeah, I see you have it next Monday. Basics of magnetic data processing. Yes, during that training session, it will be run by geophysics Professor Yanis Karush. He'll definitely be able to answer these questions more specific and yeah, more best approaches for certain data collection. I'll focus more to explain how we technically can create such routes to be able to fly in such areas. And yeah, and actually, next topic would be planning of the flight where we can combine rangefinder and AGL altitudes. But right now, maybe we could take some 10 minutes break, and then after the break, continue already with more complicated route planning and flight planning. Okay. Yep, 10 minutes will it be fine for you? Maybe you want to grab some coffee, we can take also longer. So it's
Okay, okay.
10 is fine. Yes.
Any-
Okay.
Okay, okay.
Okay. Okay, we can continue when you're ready. Okay. Can we continue? Okay. Maybe you can shortly explain the areas where you will have to perform the surveys. What type of terrain there is and what obstacles. So one case scenario I understand those are trees, 40 meters. Maybe some other scenarios, and I can uh, show how maybe best approach is how to plan the routes. Okay, understood. Uh, okay, so in areas with vegetation, their best approach would be use AGL flight mode. Yeah, because I've mentioned that if we fly using the altimeter, so if we fly over such area, then the altitude be maintained from the vegetation. So if there are trees, so if they are very close to one another, then of course the drone will maintain altitude close to the branches. But I think technically it wouldn't be possible to maintain the same altitude above the ground if using the altimeter, because it will adjust, so it will go up and down and try to adjust, and if at some point it's lower than the trees, there's a risk of hitting it. Okay. But the ground elevation is expected, so I understand that it will be the forest, but will it be flat, or also there'll be some hills and something like that? Okay. Yes. Yes, if you fly over vegetation, then AGL flight, so barometric altitude will be better, because altimeter, it will react to all changes. So it will because altimeter gets a reflection from the vegetation. So it's not measuring from the ground; it's measuring from vegetation. With a barometric altitude, then all the altitudes would be set relative to digital elevation maps, and everything calculated relative to takeoff position. Um, if you create with a lidar, then when we create the route in UGCS, so for example here area where partly it is visually, so partly it's over the ground without vegetation, and partially there's a vegetation. Okay, here also some hills, something like that, but when you import your data, then you can check the elevation profile, and from elevation profile you should be able to understand if the vegetation also is in the data, or you have just the measurements from the ground. So this may be not the best example location. I need to find something flat. Okay, here still is some mountain, but so here you can clearly understand that the trees, if there's a forest, so it's not a part of digital elevation data, that all the measurements are relative to the ground. Yes, because you can see the area is flat. But with a lidar, it's possible that you get actual terrain from terrain, so you get the vegetation altitudes as well. Then you can just check how this elevation flight elevation profile looks. If there will be there will be spikes in the altitude, and you understand that it actually is creating the route above the trees, and it's also following the trees. There's other way, other method. We can use also AMSL altitude. In case of AMSL altitude, then the altitude will be set relative to median sea level. And here in UGCS, here on the bottom, we can see elevation. So that's AMSL elevation of digital elevation maps. And we can, for example, specify flight altitude, let's say 650. And with that, we would have drone fly at exactly at the same altitude. So the flight plan would be flat, and it would be would fly at constant altitude above median sea level. This approach it could be used if the ground itself elevation doesn't change its ground, but there are trees and they're represented in your digital elevation maps, then to prevent from the pass being calculated from the top of the trees and adjusting the altitudes, you can use AMSL type, and then it will be flying just on a straight line. But yeah, if you have already imported some data, we could check a particular case scenario, and then find out what's the best approach. Because for magnetometer, I believe the most important it is to maintain the constant altitude above the ground, constant as much as possible. Because otherwise, on different altitudes from the ground, so you'll get different results for magnetic field. So if you have this data, we can later check on the planning, how better to plan. Now I will just show yes the actually then the two other methods how we can create the routes. So one for barometric altitudes, one approach would be AMSL. AMSL actually is quite rarely used now for let's say for magnetometers or other sensors where we need to have the constant altitude. AMSL is mainly used for photogrammetry when we want from images to create terrain elevation maps. But yeah, for others we use AGL. So with AGL, then the altitude would be there. We specify already altitude above the ground, and the route is adjusted so accordingly. If there would be vegetation in this data, then the altitude would be calculated from that vegetation. During this flight, then yes, altimeter will not be used. So altitude will be maintained based on the barometric pressure and GPS. And additional risk then comes in as the downwards obstacle sensor is disabled. So there's no ground detection. We have safety mechanism. So when the drone flies in the AGL mode, if it's the flight is controlled by the SkyHub, then we're still looking for the altimeter readings, and if altimeter readings goes below minimum, then the failsafe is triggered. This can be used as additional safety measure, but then you still would need at least one point on the route with the rangefinder altitude mode. And for the rangefinder, depending on which altimeter using, if it's laser altimeters, then maximum altitude is 90 meters. If radar altimeter, then the maximum altitude is around 50 meters. So in such case, then I would set the first waypoint, which would be over the flat ground at some altitude close to what it would be flying, or actually it doesn't matter. Just to start with the altimeter, then to be able to create a higher route would again require to update the drone profile. There we have the maximum rangefinder distance, so it's maximum at which we can operate, and then we can set 50 meters, so we'd be able to create route. So in this case, in this case scenario, so the first waypoint, then the drone would take based on the altimeter, and then it would switch to a barometric altitude. But during the flight, the SkyHub, so the flight would be controlled by the SkyHub, and SkyHub would be checking this minimum altitude value, which you can set definitely much higher. And if it detects that it's too close to, for example, to trees, then it would trigger the failsafe. It's not commonly used scenario, but if you want some additional safety, considering that the downward sensor is disabled, then that could be the use case. But that would require some trial flights to understand how it affects, because to not get too much false positives. Um, if you can maintain just set high enough altitude, so you do not need to worry about these vegetations and trees and so on, and you can fly safely on just on barometric altitude, then use a very simple scenario. So you create the area scan, set the AGL altitude, and just fly the automatic mission. Um, yeah, and that's actually standard approach how we create routes and how we fly with native DJI Autopilot, not using the Skyhub. Um, for if you need to cover large areas, then that would require the change of battery. Then in this case scenario, when you flying AGL altitude, it's highly suggested to set the first waypoint near your takeoff location, which would be actually higher than any possible obstacles on the route. So let's say set some 70 meters. So the altitude from which you can reach any position on the route on the straight line, not worrying about any obstacles. And so that's used for a case when you need to change battery in the middle of the flight. So for example, you call drone black from position on the route, and then when you resume the flight, the drone first performs, so it takes up to this altitude, and then goes straight line to the survey area, and then descends already to target altitude. With this approach, you can just perform survey the areas with different with the elevation changes, and be sure that the drone always will be at the same altitude when traveling to the resume location. Um, okay. I still need, so with the areas you described, I'm not certain if that would be useful, but mm, I just showed, so maybe maybe in some case scenario it can be useful. So we can it's possible to combine in a single road segments with rangefinder, altitude mode, and as well the AGL. So for example, the area where we have the ground and where we don't have any vegetation, we can set the flight altitude using the rangefinder. So there will be navigating the flight altitude based on the altimeter, and then we for the area where we have vegetation, we can just create another polygon. Nearby polygon. But for this, we can use set altitude mode AGL and fly using barometric altitude. So one part will be the rangefinder. Oh, okay. So altitude still must be in the maximum range. So we can combine two different segments in a single route. But such route then would definitely need to fly using the SkyHub. If we use only AGL points, then we can fly using the native DJI autopilot. If you have if you have some location where you plan perform maybe some first test flights, you can actually share the screen and yeah, we can pre-plan the route which you need to fly. Would it be useful? How do you think? Yes. Okay. Would you like to share the screen so we can go through the planning process and I can guide you and maybe suggest something? Or yeah, if computer is not yet set up, then yeah, after some time we can have a break. You can prepare the computer and then we can go through. I'll then just now finish with this process. How we do it. Uh, so you mean you haven't collected yet any elevation data from using the lidar, yes? Uh, uh, okay, understood. Um, Yes, because yeah, because previous trainings that was yeah UGCS and this was actually all. Mm, so the main case scenarios how you're flying using the AGL mode should have been explained, but yeah. So but the flights with altimeter. So would you also consider those that there would be areas where you will flying using altimeter, not AGL mode? So will all the areas you need to fly be with vegetation, so where you will need to fly in AGL mode, or you consider that there could be also areas which where you can where you would use altimeter? So the rangefinder mode.
Sorry, we don't understand what do you mean. Maybe.
No, so
Ah,
so with what I understood that you're performing the surveys now and using the lidar, you're collecting the digital elevation maps where will be vegetation, so canopy or trees, and where it's safer to fly using the AGL altitude. But will you also have the areas without vegetation? vegetation where you can fly using the rangefinder mode. So based on this altimeter altitude. Or all areas are planned to be with some level of vegetation. Okay, understood. Yeah. Then most probably the AGL flight planning method would be the best. But what I can offer from our side, so first of all, during this next training session, which you have on Monday, there you can definitely discuss it and ask how, from data perspective, and what altitudes and what would be the best flight planning approaches. And then when you have this, when you will be already preparing for the survey on certain location with the survey data, you can request the session, and we can assist you in this flight planning process already for the specific location with specific elevation data. Because right now there is a lot of theory, and I can try to cover as much as possible case scenarios, but that would probably be a lot of actually unuseful information for you, which can be confusing. So working on assisting on your specific locations, I think that could be more useful and more productive for you. But okay, yeah. So it's just an offer. Yep.
Sorry, can I use the share screen for share
Yes.
my area survey with
Yes.
Google Earth? Okay, thank you. So this red box, the planning, we survey Magnimbus at Aceh. We have some concern about the north because there is very rapid vegetation. Sorry, the internet is not good, so the another area is not clear.
Okay. Yeah, I understand. Yes. No. I see. Yeah, this will be quite a specific use case. I will. I'll talk. I have a meeting today with Yanis Karish, who will be running the training next Monday to you. I'll offer that uh, maybe during next Monday or during that session. So he'll cover all the specifics of magnetometer, and then I can join during the training and. Already knowing his recommendations for the data, then we can discuss in details what would be the best approach for the specific areas, for the specific data requirements, how to plan the flight. So yeah, to that we could return next Monday. Then now I'll still cover so the flight process, how you execute and to have the data collected on the SkyHub.
Okay, I understood. I have a question.
Yes.
When we can explain the training about the obstacle avoidance at the sensor Magnimus sensor?
Oh, yeah, that I can explain still now. That's a part of this session. So
Okay, thank you.
yeah. So about the obstacle avoidance sensor. Yeah.
Oh yeah.
So obstacle avoidance sensor. So can you can see my screen, right?
Okay. I can see your screen.
Yep. So the obstacle avoidance sensor, which you install additionally on top of the drone, so that's a radar sensor, and it has a vertical beam of 15 degrees, and it has a side sectors azimuth beam around 100 degrees. So if the sensor is installed under the zero angle, so simply say 90 degrees relative to the drone corpus, so it is scanning around 50 degrees also downwards. So depending on what sensor angle you install, how you adjust this sensor angle, based on that changes at what distance it detects the ground as an obstacle when we are flying just over the flat surface. The maximum detection distance for the optical sensor is around 40 meters. Yes, so that would be the 40 meters is actually unreasonable to set as a detection distance. Say we need to select some reasonable distance to the obstacles at which the failsafe is triggered. Because during the flight, so it's possible to set 4 types of action. How what failsafe is triggered when the distance to the obstacle below becomes too short. So a default action configured on the SkyHub is return to home. And that's most commonly used if you need to fly below visual line of sight. So when you you let drone fly below visual line of sight, so with native DJI obstacle detection systems, the drone will just stop, so it will not continue the flight. Yes. If you fly below visual line of sight, and when obstacle is detected, you cannot adjust actually manually, so you can use action return to home. So drone flies, it detects obstacle, so we cannot continue fly on the same path. So return to home is triggered, and the drone is returning to home position. Other possible action is stop and hover. So the drone flies, it detects an obstacle, it stops, and then you can adjust the flight path manually and continue the flight. So those are two possible actions. The configuration, the action, which action is used, that we need to configure in the Skyhub configuration file. The safety distance you can adjust during the process. Yes, a question? Yes, please. Yes, they that's actually that can be configured, and so by default we turn off only downwards sensors. So the Skyhub obstacle detection system, it also by default it uses DJI front sensor, back sensor, left, right, and up sensors. So by default, those sensors are also used. If you want, you can disable and only rely on this attached obstacle sensor, but by default, all those DJI sensors are used as well. So avoid the obstacle. No, unfortunately, that's that's not yet working. So this the same as DJI sensors. Unfortunately, also the sensor which you're using, it can only be used to prevent from collision, not for the navigation. Yes, yes, yes. So depending on yeah, so depending on which you can choose, the closest possibly would be to use stop and hover. So you can adjust the flight manually, but automatic adjustment to the obstacles, that's not yet working. Okay, yeah, to fly using obstacle detection system, you wouldn't even when you fly with in AGL mode. Yes, and that's a tricky question actually. Not certain if we fly using the native DJI autopilot, the Skyhub can don't think it can interfere. So that means it would be necessary always to use this approach say we'll plan the flight plan in the AGL. But we still would need to have additional rangefinder waypoint. Flight is controlled by the SkyHub. That's necessary for obstacle avoidance system to work, because otherwise, if we don't have this rangefinder point, then DJI Autopilot will control the flight, and there the action. Then, first of all, this additional obstacle avoidance sensor is not used, and other thing is that only native DJI system will be working, and there we cannot modify the action, so it only stops. So it's not possible to set return to home. Yeah, it's actually an unusual scenario. So from the all details which I know, currently know, then the flight process would have to be following. So the flight planning, so for route to be flown using the SkyHub, then we need to always set first the waypoint near probably near the takeoff location at the rangefinder altitude mode. Then to be able to resume route. No, it gets very difficult actually. I just need to think how correctly to provide, because the problem is if we have all segments AGL, then the route is uploaded only to DJI Autopilot. So SkyHub is not in control of the flight, and obstacle detection system also is not controlled by the SkyHub. So to have route uploaded to the SkyHub, we need to have at least one waypoint in the rangefinder altitude mode. And rangefinder altitude mode, then it limits the whole route to the maximum rangefinder distance, and that means we need to actually create a workaround. So we would need to increase maximum rangefinder distance to be able create AGL waypoints at the necessary altitude. And rangefinder waypoint, we cannot have the first one, because the first we need to have it above all the locations. Then probably the best option would be to use the SkyHub, would be to set waypoint after the main survey area, and set it at rangefinder altitude, and probably even to the maximum, let's say 30 meters. So then the route planning would be the following. So we have all waypoints except last one. We have AGL, and last one we need to have rangefinder for route to be uploaded flight is maintained based on the and obstacle detection system also is working. AGL, so we can set it high enough, so above all positions on the route, to be able to resume route from the battery after the battery change from any position. Because I believe the areas will be very large, and when planning the flights, you will need to change battery. Do I understand? Yeah. So that would be probably approach. Yes. So yeah, this would be approach then for the planning. So first waypoint you always set at the altitude at which, in traveling in the straight line, you can safely reach any position on the route. Then the main area where you set AGL altitude, so about digital elevation data, and last waypoint probably some 30 meters, which so at the last position, then the action will be following. So the drone will finish the flight plan based on the AGL altitude, and then it will move switch to the altimeter and go to this so 30 meters above any obstacles, so based on the altimeter. And once it finishes the flight, so it will ascend to the safe altitude. This last point you can even set at somewhere very near to the last position. With this approach, so you can let the drone complete the route, and at last point just perform to a safe location. If you can maintain the connection during the drone, so to be able to intervene manually, again, that would be the still the workaround to have the route in AGL mode. Then you can select create some longer distance, or say additional waypoint AGL, just to have time to manually to take control over the drone manually. So once the route is complete, the main survey is completed, drone will be moving still on the AGL altitude, and during this positions, then you have to take control over the drone manually. I will actually discuss this use case today. We had development meeting. Maybe we can even develop some changes that would allow to fly just with DJI autopilot and still active obstacle avoidance system with the Skyhub. But currently, this would be an approach which I suggest to fly. But to that, we can also yeah, I can talk with the team there what are the suggestions and maybe solutions, and then next Monday after the magnetometers magnetic data session, we can discuss then the actual flight planning. Sorry. Yeah. Okay. About the data collection itself, I'll just show the video. So how we with the flight process to. So for Skyhub to for flight to be controlled using the Skyhub, and in this in your case, so even if you will be flying AGL flight, most of the route will be AGL waypoints, so still altimeter will be in the play, and then altimeter can work as a safety measure instead of the downwards obstacle sensor system. So to detect if the altitude goes below the minimum value you can set, so then the failsafe is triggered. And the obstacle detection system, that would work automatically as soon as the drone reaches certain parameters. So you can configure minimum altitude at which obstacle detection system is armed, and activation speed. And so then in your case scenario, it sets that yeah, activation speed is 0.2, and activation altitude can be some 0.5 meters wouldn't be reasonable, as you will be flying high, so you can set probably some 1 or 2 meters depending on what minimum altitude you would choose to have as a safety. And so to start the flight, then the flight process would be following. So from UGCS desktop client, you just upload the route. So that would be the only command which you execute from UGCS. So you upload the route. The next step is to perform the manual takeoff. And with Magnimbus, manual takeoff is mandatory because of the sensor automatically. Most probably the drone can take off automatically, but manual takeoff would be the safest option. So you always need to take off manually. Then when the drone is in the air, so it must be in the altitude range for the altimeter, so higher than minimum, lower than maximum. Then you activate the terrain following, so that would work like activation the auto mode. So you do not press auto mode in UGCS, because that's to activate flight on autopilot. Instead, you use activate button in custom payload monitor to activate flight from the Skyhub. And then there'll be confirmation asked in CPM application to activate terrain following mode, and then it already starts the flight automatically. Other way to activate flight is using the flight mode switch button on the remote controller. For it to be working, you need to disable multiple flight modes in DJI Autopilot application. Then you can activate the flight by changing from N mode to F. So it works just as a trigger. Start flight, stop flight. And using this mode switch button, also you can pause and resume the mission during the flight. So pilot during the flight, if it's necessary to return, for example, to return drone back to composition, just switch different mode, different position, and flight is paused. So, and you have full control of the drone manually. This pausing also can be done from the computer, but most convenient, I believe, is for the pilot who's holding the remote controller, so he can pause the route and then fly for the battery change. Also, pausing can be used if you come at the location, so where you need to fly around or over some obstacle. So either obstacle avoidance system detects something and you need correct the route, or you just want to skip some part. I'll show on the video how this pause resume works as well. Loading file. So pause resume with Skyhub running the flight. So if you fly in auto mission, which is controlled by the DJI Autopilot, you can hold the route. You can move back and forward on the route and believe change the drone heading. But when you resume, it will be resumed from the same position where you previously put the route on hold. With the SkyHub in control, we can pause the flight. So pressing either pressing pause button on custom payload monitor or using the mode switch button on the remote controller, then you can control the drone manually. And in this example, for example, skip the part of the route. For example, if we have some obstacles there, something like that, and then the route is resumed. When we press resume, it's resumed from the next closest position on the route. So this allows us to skip some part of the route where there are some obstacles and where we cannot fly, and we can resume the route from any unfinished position on the route. So now in this example, so the route was paused here, then drone manually was flown closer to the next line, and after pressing resume, here we can see the mark from which part of the route is then resumed. And then the drone first it turns to the resume position, then flies to the position on the route from which it needs to resume, and then resumes the flight. And that way, using either the pause button on custom payload monitor or switch button remote controller, pilot is fully in the control of the flight. If necessary, can pause the route, adjust the flight, and continue from the closest position on unfinished route. It is not possible to resume route, let's say, from the waypoints which are already completed. For that, then it would be necessary to upload route from scratch. Data recording on the SkyHub. So that starts automatically as the drone is armed. So with Magnimus connected, so you'll have a magnetic data widget. So you can add a magnetometer widget, and you can see that data is reading. Once you arm the drone, the data collection recording on the SkyHub is started automatically, and it continues until you land the drone and disarm the drone. So during the flight, you do not have to worry about data recording. If you want, you can press here the stop button, and that affects the recording. So when you press the stop button, the previous data set is closed, and instantly are created new files. So that way, during the long flight, by stopping, you can just split the data files. But otherwise, the data recording continues through the whole flight automatically, and you do not need to separately switch on. Okay. Would there be any other questions? Okay. Then I will today discuss with Yanis how regarding the next Monday how the call. So and also specific use case with either with Yanis and also with my colleagues. Maybe there will be some suggestions how more optimal to perform such kind of surveys, and next week, then based on suggestion, review again this planning process, and that part will be most probably already on what settings we set on the route. Right now, is there everything clear about how to start the flight, starting the flight, pausing, resuming? Maybe some questions on this part. Once so once you press the pause, yes, button changes to first of all, you see here in the log pausing the train following algorithm, and button changes to resume. After you press resume, yep. And also, if you pause the route using the stick, this switch on the remote controller on the computer, it will also change from pause to resume button. So you can do pausing and resuming from both, either from remote controller or from the computer. So in the field, this allows actually partially to be in control also for the person who is near the computer. A person with remote controller always has full control of the drone. So when drone flies into backup is controlling, the drone will not respond to the input of sticks. Yes, but as soon as you press the mode switch button and triggers the pause, the pilot with the remote controller can fully control the drone. The person near the computer can press the pause, so drone stops and hovers. Yeah, I'll just show that with the emulator, so how it works in the software. Okay, so to show this process, I'll just use the route using the emulator. So the flight, how it will execute the flight will be a little bit different, but the order how we upload the route and the next process will be exactly the same, like with the DJI drone. So when we start the flight, so here in this actually would be the same like you would do when flying with DJI autopilot, not using the Skyhub. So you'd upload the route. After the route is uploaded, no, okay, route is uploaded. We switched. So with DJI autopilot, you would manually perform the takeoff because of Magnembos sensor, and then switch to auto mode. So drone then it automatically starts the flight, so it ascends to the target altitude. And during the flight, while we have the connection between the remote controller and the computer, on the computer we are receiving the drone telemetry, and based on telemetry, we are tracking the route. So which part on the screen uh, you can see that the part which drone has completed is colored in the darker green color. This allows us to keep track of the route, what we have completed. And here I'll wait. Just trigger return to home because I cannot control this using a remote controller. So once we return, so we fly drone for the battery exchange. The position on the route from at which we stopped the auto mission. So we have this position on the route. We can see it. After the battery change, we can resume route exactly from the same position, or as well we can start the route actually from any position on the road. So after we have interrupted the route in the active mission, we have changed the battery, and then to start the flight, we need to upload the route again, because as soon as the drone has landed, the route details on the on board are removed. So we need to upload the route. Then after the battery exchange, we have following options when we upload the route. We can use continue, then technically the new route will be uploaded to the drone, and it will start from this position. Other option, we can specify waypoint number. So if we move mouse over the route, we can see the waypoint numbers, and we can start from any of these waypoints. And but for your use case, as I mentioned, we need to have first waypoint at the altitude from which we can safely reach any position of the road. And then we would need to mark this checkbox, fly through the first waypoint. And then, for example, I'll show just how it works, and resuming, let's say, from waypoint number 24. So I'd like to resume route from waypoint number 24 and fly through route's first waypoint. So if we use this approach, then if we do not check that fly through the first waypoint, then the drone, after we activate the auto mode, it would take the target waypoint altitude, so the altitude of this waypoint, and fly in a straight line to this position. If you fly in the area with changes in the elevation, it could happen that this waypoint is actually even below your takeoff location. Yes, so for example, you fly down the hill. So for safety, to not hit the ground while moving to this waypoint, we use this option, fly through route's first waypoint. Then when we activate the auto mode, so the drone first would fly to the first waypoint. So first waypoint we have somewhere near close the takeoff location. So it would first move to this waypoint, and then already at this altitude, which is safe to travel to the server location, then it would fly already to this resume position. And that's just a safety measurement when we fly in the areas with different altitudes, so to be able to safely reach to the resume position. And this way, so we can resume route by uploading exactly from position we previously finished, or from some corner. From data collection perspective, the recommendation is always to resume route and pause actually for the battery exchange at these corners, because otherwise, if you pause it somewhere in the middle later on when you work with data post-processing, for that area, you will not have good data. Yes, but there needs to be found a compromise between effective usage of the battery and the data quality. Because if you are flying very long lines, it might not be reasonable um, to finish to call drone back from the corners, because for example, if this distance is, I don't know, 500 meters, the battery still would be enough to fly a half of the route. And some customers are for more efficient battery use, they're just using this continue option and continuing also from the last position. That's if you need to cover very large areas, you need to perform, for example, 20 battery changes per day. Then uh, uh, is more effective in scope of the time usage. But the data quality, the survey data quality may, yeah, then in those points, that might be an issue. But it depends also on the sensors which are used, and how later on you work in data post-processing, how you stick the data together. But so different approaches are possible depending on what you prioritize, data quality or time efficiency of battery, and how important is this resume location, because technically the drone, it will come to the same position, so it will resume from exactly the same position. Okay. Anything else? Okay, then yeah, then we can close the session for today. Probably tomorrow I'll send an email regarding the next Monday schedule. So how you just to confirm. Yes, and yeah, then probably then see you next Monday. If you have any questions so far, uh, if you have any questions, you can send me an email, or better, it's to send to support@ugcs.com. Then it reaches the person who's most advanced on the topic. And yeah, for then for this next Monday, if yeah, the more details you can prepare for regarding the specific locations, it doesn't necessarily need to be. You don't need exactly to have these digital elevation maps ready, but when you have them, then we can just work on already specific location to plan the flight for exact position. Okay. The recording of this meeting will be available starting from tomorrow, probably, because Zoom takes some time to prepare. I'll also share this presentation. So the flight process steps are actually yeah, would be the same. Just this mission planning specifics I probably need to adjust a bit for your specific use case. Okay, then thank you for the time today, and yeah, probably we'll see you next Monday. Okay, thank you. Bye.